here is an example of an application I built some 5 years ago in Java for Android to utilize the real-time database capabilities of Firebase. So how this worked was there's a thing called Nems, and this is just an instrument, a social science instrument, basically, which is a checklist of things to assess a restaurant for the degree of healthy offerings that it provides. And it means a very detailed, going into a restaurant and making a very detailed checklist. So this is the first page of the checklist, and it's about 11 pages long. So there's hundreds and hundreds of items on there that have to be looked at on the menus and everything in order to get a score for a restaurant called a Nems R score, Nems R scores. And so the challenge was to put this checklist into an app that people can use to go out to different restaurants, a whole team of people, and start collecting the information, and then have it all uploaded instantly to the backend database, and then subsequently analyzed, downloaded and analyzed locally. So I created this NemsR app, it's called, and it works on Android. It's an Android-only app because I did it in Java. And you can see how it kind of looks there. You'll see a better example at the end. Now, to do that, I had to build a massive object set for this. So since it's such a large checklist, I used what's called Universal Modeling Language, or UML, to create all of the items in the checklist. For example, coffee comes with sugar, does not come with sugar, etc., have to be formally modeled in some way. And that looks like this. So we have our abstract class that starts here called NemsR, which just has all the questions. And there's 25 questions over those 11 pages. And each of those has dozens of items in them. So for example, here, one of the things is location, the first one you see right at top, location. And so location has a set, or a class here, subclass, called location that has longitude, latitude, name, address, and any type of additional properties. And then for each of those properties, there's a get method and a set method. So methods, just like in, so each of these boxes basically represents a small script in Java that provides the definition of that class and includes its functions inside called methods to work with it. So that's for the location. And then, for example, question 25 is for kids, and you can see all the properties here. Are kids' meals available? Do they come with a healthy drink, water? Do they come with pop? Stuff like that. And then each of those sub things has its own little subclasses. So it's a very large object model, obviously, because it's collecting so much stuff. So that had to be then created or exported as a JSON file, so a JSON object, which is like a Python dictionary, although it's very, very large. Just talking a very large type of thing here. Just as an example here, here's just for one small question, it looks like that. So that shows you kind of how Java code looks. And the big one in the middle, the abstract class, looks like that. It just has stubs out for public functions for each of the methods, or each of the different questions. So it knows where to store those things after, and it kind of looks like that. Give you an idea. So that big object model then is created as a JSON, is exported as a JSON type of string, a very large one. And that can then be imported directly as the data structure. So this is the data object structure for each checklist for each restaurant. And that's uploaded to Firebase as a JSON script. And you already know about how that works. So Firebase. And this is an example just of how it works, just a small demo. Here, using the authentication in Firebase. So only authenticated users can use the app. Obviously, we don't want the public using it and messing up our database and stuff like that. So only team members are allowed to log in and use the app and record stuff in the backend database on Firebase. And just showing here on the right-hand side, the actual Firebase item. And every time something is changed on the local phone, let's say, like the name here, you can see on the right, it will add a new item once the location is set. And then you can even look on the phone to see where that is to make sure it's in the right place and move the point to where it should be if it's not in the right place because maybe your GPS on the phone isn't working right. So for example, here to second cup, and when I move things and stuff over there, changes happen in real time in the backend database. And this was important so that there were no overlaps. People can go in and check, and see if the same restaurant is being done. And back in the office, we can see who's where in the team, how much they've done in real time, and put that on maps to see how the progress is going throughout the data collection period, which was the summer, obviously, when there's less teaching to do. So there's more research that can be done. And so every time something changes, it happens in real time in the database. And so it's always state of the art, up to date in the database for everybody in the whole team anywhere will be able to go back and see any of these in real time as well. And so that's just an example of how Firebase is used. It's not the only app that I did in Firebase. Many years ago, so Firebase didn't exist. And prior to Firebase, there was parse.com, which was Facebook's real-time database called parse.com. So I built earlier apps in Parse using Parse, and then I translated them once Facebook stopped Parse for public use. Firebase then was the main option around for real-time database creation. Because as I said, the programming behind creating a real-time online database is difficult. So it's not something you'd want to take on yourself to create a real-time database. It's something you would do with an existing service like Firebase. So having Firebase really takes a lot of the intricacies of trying to deal with real-time data and authentication off the developer's lap, so to speak. But they're very useful.